Hey, here we are with a nice cool drink outside, enjoying the sunlight and the fresh air. It's just a great place to learn a little more about electronics. Follow along. This is episode 2, Components. Before we get started, I want to thank everyone who commented on episode 1 in YouTube. Keep your comments coming, they're great. Okay, so today we're going to talk about components. And I don't mean like the components of your stereo system at home. I'm talking about the types of components that we're going to need to learn about so we can put really cool electronic circuits together. Some of the components that we're going to talk about are going to be what's known as passive, and others will be active components. And there's a very large selection of components, as you can imagine. We're not going to try to cover every single one here, but we're going to at least try to give you some ideas of what exists. The class of passive components include resistors, capacitors, and inductors. So we'll begin with the resistor. The resistor is a component that is used to limit the amount of current that is flowing in a circuit. It's also used to reduce or drop the amount of voltage in a circuit. Later on, when we start working directly with resistors, I'll explain to you exactly how it is that the resistors allow us to either reduce the current in a circuit or drop the voltage in a circuit. Capacitors can perform different functions. One is they can block DC current. 2, they oppose the change in voltage. And 3, they behave like a filter. The third passive component we're going to talk about is called an inductor. An inductor is similar to a capacitor, but it behaves a little bit differently. In the case of a capacitor can be charged up and it will hold that charge. Well, an inductor behaves a little differently in that it actually holds energy by building a magnetic field, just like in a magnet. And because it has a magnetic field that gets generated, when you pass current through an inductor, it tries to oppose the change in current. So in a sense, it behaves kind of like the capacitor does when it's blocking voltage, but in the sense of an inductor, it's actually blocking or resisting a change in current. And we'll talk a little more about inductors later on, but I just wanted to kind of give you an idea of what inductors are all about. The next class of components that we're going to talk about are active components. And active components are those components that behave a little bit differently than these passive components. Wow, isn't this great? 2 episodes and we're already talking about semiconductors. Man, I remember it took a whole lot of school and time for me to get to the point where we talked about semiconductors. But, you know, since we're doing this for fun, we don't have to follow the rules that you follow in school. And as you see, there's no books here. We're not really interested in digging into equations or looking at circuit diagrams right now. We're really focused on just trying to figure out what these semiconductors are all about. So let me talk about the diode. The diode is probably the most basic semiconductor that we can work with. And when we talk in more detail about semiconductors, we'll understand why it is they behave the way they do. But for now, let's talk about how a diode behaves. So a diode is a semiconductor that is used to allow current to only flow in one direction. And there are some interesting circuits that we can build using diodes. And the way that diode operates is that it consists of a component with 2 connections. One connection is called the cathode and the other connection is called the anode. when the cathode side of the diode is sitting at a voltage level that is lower than the voltage level on the anode, the diode is said to be forward biased and it will conduct current. Now the symbol for a diode is an arrow with a straight line at the pointy end of the arrow. And so when we talk about current flowing through the diode, it flows against that arrow that you see. Now, there are two ways to look at flow of current. You can look at it as the conventional or the electron flow method. I'm not going to go into those details right now because there's a lot of books out there that can tell you what the differences are. For right now, let's just talk about the fact that current is flowing and it's flowing in only one direction. If you want to know more about the diode, just leave a question in the comments and I'll answer it. Okay, transistors are a slightly different class of semiconductors. They're like the diode, but there's an additional lead connected to a transistor. So the transistor itself has basically a structure that's very similar to having two diodes connected together in a circuit. And the idea with the transistor is that because of the way it is configured, it has the ability of amplifying a signal. And I know we haven't talked about amplifying, and you guys probably only understand the word amplifier from your home stereo or from your clock radio. And that's okay, because we really don't need to dig into the details. All we need to know is that if we have a signal of a specific level and we feed it into a transistor circuit that has the ability to amplify that signal, then the signal we see at the output of the transistor will be much greater than the one that we put in. And that difference that we see from the input of a transistor circuit to the output of a transistor circuit is known as gain. So as I mentioned earlier, a transistor is very similar to a diode, but there's three leads. And those leads that connect up a transistor are known as the base, the emitter, and the collector. In a standard circuit with a transistor, we can control the current flowing from the emitter to the collector, and we do that by controlling the voltage that's imposed on the base of the transistor. Now, we're not going to go into the math here about how a transistor can control that current, but to use an analogy, it's like the valve that you have on a faucet. When you turn the valve, it lets the water come out of the faucet. The more you open the valve, the more water passes through. So the transistor operates the same way. If we increase the amount of current going to the base of the transistor, then the amount of current flowing from the emitter to the collector will also increase. Ooh, I really needed that. Every transistor has what's known as an amplification factor, and that amplification factor defines how much gain a transistor can have in an amplifier circuit. We'll talk about this in more detail when we start talking about amplifiers using transistors. ICs, or integrated circuits, makes it really easy to build really complex circuits with a minimum number of components. That's because they take all the different components that we need, they shrink them, put them on a piece of silicon and interconnect them. Then we have just a single chip that we need to hook up and wire to make our favorite circuit. Remember, it's all about having fun learning electronics. Enjoy your cool drink, the nice atmosphere, and tell me what you think. I'm Guru Santiago. Thank you.